Okay, so I'm doing number 30 on page 111. The problem reads, an object with mass m1, which is equal to 5 kilograms, rests on a frictionless horizontal table and is connected to a cable that passes over a pulley and is then fastened to a hanging object with mass m2, which is equal to 10 kilograms, as shown in the below figure. What's the acceleration and tension in the cable? Okay, so I start off with drawing my free body diagram. I showed the little mass and the big mass. You need to draw different forces for each one. I showed mass times gravity and normal, but in this problem they don't matter because it's on all the direction is horizontal and it's on a frictionless surface. So I just showed that this with this. And so the only real force acting on it, well, the only force you need to know for this problem is tension for this one. For this other mass, we have mass times gravity and tension, and during the problem I'm going to be showing that this mass, I'm going to be representing this mass by little m and this one by big M. This one is larger. This one's 5 and this one's 10. So for this mass, I wrote the equation T equals ma because tension is the only force acting on it. And for this one, I wrote the equation mg minus T equals ma, which I eventually solved for T and got T equals mg minus ma. I then combined these equations to get mg equals, or little ma equals big mg minus big ma. Then I got to this equation, which I used to solve for acceleration. And then once I solve for acceleration, I just plugged it back into, you can plug it into any of the equations, but I just plugged it in this one because it's simple. And I got the tension being 32.6 newtons. And acceleration and tension are obviously the same for both of these because they're connected by a pulley.